Hello everyone. In this presentation, we are going to discuss about the need for the real-time operating system. When we study microprocessors and microcontrollers, when we work with 8051 microcontrollers, while simulating the arithmetic operations like addition, subtraction, multiplication, divisions, while simulating the logical operations like AND, OR and XOR, while simulating the searching operations, while simulating the sorting operations, while simulating the code conversions in the Keil IDE, we never thought about real-time operating systems. We are somewhat comfortable with. We are so much comfortable with the Keil IDE simulation. When we go to the hardware experiments by using the development board of 8051, while we talk about interfacing LED, 7-segment and LCD, while interfacing push-to-on keyboard and matrix keyboard, while making use of on-chip peripherals like timers, counters, interrupts, UART, and integrating both the on-chip peripherals and off-chip peripherals. We were never thought about real-time operating systems, but now it is mandatory for us to look at the real-time operating system, where the real-time operating system is necessary and how it is necessary. As discussed in the previous presentations, whenever the tasks, that means there are interrupt service routine, they are called as tasks, ESR tasks, and there are some tasks of the main routine. When there are timing requirements, then definitely there is a need for real-time operating system. Say for example, so far we never work with timing requirements except display refreshing. Display refreshing needs timing requirement, where once in 8192 microseconds display has been refreshed in an entry exit system we have experienced. Other than that, there is no much timing requirements in our application. That is why we are so much of comfortable except the display refreshing. Similar to display refreshing, display need to be refreshed once in 20 milliseconds. Similarly, if we are connecting a microphone for reconstructing the speech signal, it has to be sampled once in 125 microseconds. Speech signal need to be sampled in 125 microsecond and display need to be refreshed in 20 millisecond, and every task comes with the timing requirements. To satisfy the timing requirement by ever conventional programming may be difficult. Hence, it is mandatory for us to make use of real-time operating system for a complex applications where the timing constraints are more important. That is what we are going to discuss, and while discussing we will come to know the significance or the need for the real-time operating system in detail. So in this discussion, right, in this slide, look at the screen. So although simple applications can be programmed on a microcontroller by writing a single piece of code, that is what we did so far. Many applications are sophisticated enough that writing on large programs does not suffice. So when multiple operations must be performed at widely varying times, a single program can easily become too complex and it is very difficult. Okay, so there is a need, there are some terms which are associated with the operating systems. That is why I am introducing some terms here. So there is something like a process. A process is simply a unique execution of a program. Okay, so it is a unique execution of a program. The process is defined by both its code and data. So process includes code as well as its data. That's very important. So two copies of a single program executing on their own data constitute two distinct processes. A single program executes on the own data means it is two processes. So dataset for a process includes not only the CPU registers but also main memory. As we discussed in the shared data problem, temperature 1, temperature 2 are the main memory which is data memory locations. CPU registers, your accumulator A is a CPU registers. It includes the main memory and the corresponding CPU registers because data and code is significance here. Since the process results may be stored in both, as told, right? The process results may be stored in both. The temperature 1, temperature 2 data are stored in the data memory, which is main memory, and also in the accumulator, as discussed in the shared data problem discussion. So process defines the state of an executing program. It defines the state of the execution program. Okay, so one commonly used form of process in embedded system is the lightweight process, also known as thread. Okay, so there is a term called thread. Lightweight process is called as thread. It is one interesting thing you need to understand. Okay, there is a term called operating system. There is a term called operating system here. Operating system provides the mechanism for switching execution between the processes. Operating system provides the mechanism for switching execution between the processes. The operating system's fundamental job is to allocate the resources in the computing system among programs that request them. Okay, so CPU is the important resource. So scheduling the CPU is the operating system's most important job. So satisfying the complex timing tasks can introduce extremely complex control into the programs. Using the processes to compartmentalize the functions and encapsulating in the operating system the control required to switch between the process makes it much easier to satisfy the timing requirements with relatively clean control within the process. So real-time operating systems are the operating system which provides facilities for satisfying real-time requirements. Okay. So this is a quick summary about the operating system. But here, in short, what is operating system? An operating system is an interface between the computer user and the computer hardware. An operating system is a software which performs all the basic tasks like file management, memory management, process management, handling input and output, and controlling peripheral devices such as disk drives and printers. What do you mean by real time? If the execution time is 100% predictable, then it is real time. What is a real time system? If the system's execution time is 100% predictable, then it is a real time system. Without missing any deadline, the system has to execute all the tasks as per the schedule means, then that system is going to be the real time system. What is hard real time system? Oh, real time systems are broadly classified into hard real time systems and soft real time systems. If the missing of deadline is not tolerable, then it is hard real time system. Okay, so that is what one good example is. To process the speech signal from microphone, speech signal need to be sampled 8000 times per second to satisfy the Nyquist sampling theorem. So missing of deadline, that means missing to take 8000 samples. Even if we take 7999 samples, it results in poor audio quality because it misses the Nyquist sampling theorem. So 8000 samples need to be taken in 1 second. Missing a single sample in 1 second out of 8000, even if we take 7999 sample, the audio quality will be disturbed a lot. Hence, missing of the deadline is not tolerable. Hence, speech signal processing and audio signal processing are the good examples of hard real-time systems. Okay, so digital audio processing in general is a good example for a hard real-time system. What do you mean by soft real-time system? If missing of deadline is somewhat tolerable, then it is called a soft real-time system. For example, our video signal processing. It's very interesting. So video signal processing in a screen, that means normally 50 frames per second is the PAL, CCAM and NTSC's television standards. Missing of the deadline, that means 50 frames per second means once in 20 milliseconds the screen has to be refreshed. So if every 20 milliseconds the screen is refreshing means at the end of 1 second it will refresh 50 times. So if the screen refreshes 49 times or 48 times or 45 times, then it doesn't matter. Why? Because persistence of vision is only 16 changes per second. So twice or thrice the amount is your display refreshing rate. Hence, missing of deadline in the video may not produce a big impact like our audio systems. Hence, refreshing of video is tolerable and refreshing of audio is not tolerable. Hence, digital video signal processing is a good example for soft real-time system. So, digital audio signal processing is a good example for hard real-time system. Digital video signal processing is a good example for soft real-time systems. It's very interesting. So, we all know the real-time clock. So, real-time clock means if the execution time of the clock is 100% predictable, then we can say it is real-time clock. So, the predictable time of a real-time clock is 1 second, because 1 second is 100% predictable in real-time clock. 1 minute is 100% predictable. 1 hour, 1 week, 1 month, 1 year, etc. are 100% predictable. All digital clocks, alarms and calendars, reminders, etc. is just because of real-time clock. In short, if the time delay requirements are in hours, minutes and seconds, then real-time clock is the only solution, because 1 second delay is 100% predictable. Hence, if the clock which produces 1 second delay is 100% accurately, is called as real-time clock. What is real-time operating system? If the clock's execution time is 100% predictable, then we can say it is real-time clock. If the operating system's execution time is 100% predictable, then we can say it is real-time operating system. That's what it's very interesting. If the execution time of the operating system is 100% predictable, then it is real-time operating system. For a hard and soft real-time systems, real-time operating system is needed, which is very important and very interesting. Okay, so we can see the major differences between the real-time operating system and conventional operating system. So when we say that is tabulated here, right? Here we are tabulated the difference between the operating systems and real-time operating system. So let us take the operating system as an example, like our Windows operating system. Normally we use in our PC, because this presentation is happening because of the conventional Windows operating system. So in the Windows operating system, the operating system tasks runs first, then the application code runs next. What does this mean is, until start menu comes, the operating system will initialize as like BIOS, basic input output system, and before that power on self test will happen. So power on self test, basic input output, power on self test, basic input output system, and all other necessary files will be copied from the hard disk to the CPU, hard disk to the random access memory, which is called as booting. After copying the operating system from the hard disk to the random access memory, it runs, and then start menu comes in the screen, where the operating system, as told, right, it supports the user to make use of the hardware more efficiently in a user friendly way, which is our conventional operating system. Windows is a good example. But in the real-time operating system, here it is given as application code runs first, then the RTOS function runs next. Why the application code runs first? Because when you take a mobile phone, the mobile phone will have several versions, right? A mobile phone is available for 500 rupees, mobile phone is available for 50,000 rupees. So for 500 rupees we cannot write separate operating system. For 50,000 rupees mobile phone we cannot write separating operating system. But lot of input output features will change, right, with respect to the mobile phone. Even in the same make mobile phone, different versions. One mobile phone will have single camera, another mobile phone will have dual camera, another mobile phone will have AI camera, another mobile phone will have Bluetooth, Wi-Fi, GPS, dual SIM, single SIM. So many facilities are there. We cannot write a common operating system for a mobile phone or some other higher end. So that's why mobile operating systems are available in the market, and an operating system which is dedicatedly running for a microcontrollers is called as real-time operating system for a specific task. In one case we can conclude like this: an operating system which is specially working for some specific task or dedicated task is a real-time operating system. The general purpose operating system is conventional operating system. As we discussed, right, embedded system are the systems which are dedicated to a particular application. Most of the embedded systems with timing constraints uses real-time operating system. Why? Because those applications are specific to a particular application. Say for example, anti-lock braking systems in a car, and there are so many other biomedical applications needs real-time operating system. Name itself justifies real-time. The execution time need to be 100% predictable. Within 5 milliseconds this code will execute means within 5 milliseconds exactly that code should execute. Within 100 microseconds this code should execute means it has to execute in 100 microseconds. If the operating system ensures that, then only 8000 samples will be taken by the conventional operating system. 8000 samples will be taken by the microphone to do the speech signal processing more efficiently. 50 frames will be refreshed in the screen once in second to make the audio quality much better as well as the video quality much better. So OS must ensures that. That is why this particular real-time operating system is mandatory for audio and video signal processing and lot more. Okay, so to inform the operating system that, say for example, there are several peripherals. Okay, there are several peripherals. Say for example, 500 rupees mobile phone will have 5 peripherals. For example, 50,000 rupees mobile phone will have 50 peripherals. 50 peripherals means each peripheral will have some task. Okay, so 500 rupees mobile phone will have 5 peripherals, so 5 tasks we will write for each peripheral. Okay, one task, one peripheral, one code, one function. So timer means timer need to be initialized, timer function. Interrupt means interrupt need to be initialized, interrupt function. Like this, every particular application needs to be initialized with a particular code. So 500 rupees mobile phone, 5 tasks need to be initialized. 50,000 rupees mobile phone, 50 tasks need to be initialized. So each application needs different functions and different priorities, different timing constraints. So what are all the tasks which are available is decided by what are all the peripherals available. So for 50,000 rupees mobile phone, 50 peripherals are there, so 50 functions are there. Those 50 functions are having this much of timing constraints and this much of priorities, those particular need to be informed to the operating system. Then operating system will execute or schedule and run according to the requirement. Okay, that is why the application code runs first. What do you mean by the application code runs first? Means what? The user informs or the designer informs the operating system that there are 50 tasks which are available, which serves the 50 peripherals in a complex mobile phone, and these particular 50 tasks are having this much 50 different priorities and 50 different timing constraints. So RTOS has to look after that. Whenever the peripheral is in need of service, RTOS has to schedule properly in such a way that the requirements by the application users or requirements of the application can be fulfilled by the real-time operating system. Okay, so to inform the operating system about the corresponding peripherals of a particular real-time system or hard real-time system or soft real-time system, application program runs first. After understanding that, operating system will take the charge of it. So that is what the first difference. So application program informs about the peripherals and its initialization and its peripherals and its timing requirements to the RTOS. Hence application program runs first, then the RTOS runs next in the real-time operating system. But the conventional operating system is very simple, which is our desktop system or laptop systems. Very simple. It has a common motherboard. We talk about only the processor, what is the hard disk size, whether it is 2 GB hard disk or 1 TB hard disk, what is the RAM size, 8 GB RAM or 12 GB RAM, and all the peripherals more or less remain same. One screen, one keyboard, one mouse, one hard disk, one RAM. That's all. So there may be much variation in any computers, which is general purpose. So general purpose OS. So RTOS is a specific OS where we can use it for real-time applications, or exactly RTOS is used for embedded systems. Conventional operating systems are used for general purpose systems like PC. Okay, so that is the first difference that we have to understand with respect to the conventional operating system and real-time operating system. And the second difference is operating system is not scalable. Scalable means what? Operating system can be if there are 100 functions in an operating system, means if my application needs only 50 functions, can I use the 50 functions in the operating system among 100 functions? That is not possible with the Windows. So Windows will install completely. Whether we are using it or not is secondary, but Windows takes some 1 GB of RAM space or 1 GB of hard disk space, means that 1 GB has to be installed properly without sacrificing anything. Why? Because it is mandatory, because it is for general purpose, which is not necessary to scale. Hence operating system is not scalable, which is Windows is not scalable. But when we talk about real-time operating system is scalable, and it should be. Why? Because the same operating system is not necessary for a 500 rupees mobile phone as well as 50,000 rupees mobile phone. For 500 rupees mobile phone, maybe 5 features of RTOS can be used. In the 50,000 rupees mobile phone, 50 features of RTOS can be used. So out of 50 features, 5 features out of 100 features in the RTOS, 5 features can be used in the 500 rupees mobile phone. 50 features can be used in the 50,000 rupees mobile phone. So what are all the features which we need those features can be used if necessary, hence RTOS is scalable. Say for example, we discussed about shared data problem. If our application, we may think that there is a possibility of shared data problem, means semaphores are the one of the feature or one of the facility in an operating system. So semaphores in the real-time operating system can be used to prevent the shared data problem. So it is based on the application. If the application is in need of semaphore, it can make use of semaphore. If not, there is no need for semaphore in a particular application. So whichever we need, which we can select, this is called as scalable, and it is needed for a microcontroller based application or embedded application, hence RTOS is scalable, which is the second difference. When we talk about third difference, operating system protects itself from the application code. Yes, until start menu, the C drive is totally isolated from the D drive, E drive, etc. So whenever your OS corrupts, the content of C drive will get corrupted, the D drive, E drive will be safe, right? So we can reinstall the OS and the content in D drive, E drive will never get affected. That's what OS is completely isolated from the application code in the conventional operating system. With this example, you are much more clear. But real-time operating system works along with the application code, hence real-time operating system cannot be isolated from the application code. So real-time operating system runs along with the application code, hence our real-time operating system cannot protect itself from the application code, which is very interesting. And the example for operating system is Microsoft Windows operating system and the Linux operating system, etc. And the example for the real-time operating system is MuCOS. MuCOS means micro, mu, it's a mu symbol, microcontroller operating system. So the operating systems for microcontroller itself is called as MuCOS, which is one of the real-time operating system. And there are another several real-time operating systems like VxWorks is another real-time operating system. There is another real-time operating system named as FreeRTOS, and there are so many other RTOS available in the market. Whichever is necessary, we can make use of it to fulfill the application requirement. Okay, so this is the fundamental difference between conventional operating system and real-time operating system, which we need to understand. Thank you. We'll stop with this now.